This lab is called the Hero's Engine. So in this lab, what you'll need is this device. It's called the Hero's Engine. It's basically a cup with some straws in the bottom that are bent. You can see the straws are bent at an angle like this. Now, in this lab, we are looking at Newton's third law, which states for every action, there's an equal and opposite reaction. So you can do this many ways. What's going to happen is I'm going to put some water into this cup and it's going to start to spin. Now, what I've done is I've dyed the water blue. That way it shows up on camera a little bit better. Now, what you can do is you can measure out the amount of water, but what I do is I have a cup with different lines on it. I just fill it up about halfway and I count the number of times it spins. Then I fill it up about full all the way. Then I count the number of times it spins. I just want to see how the amount of water affects the number of times it spins. Now, I also put a little line on the Hero's Engine just so every time that line gets back around, I can count the number of times it spins. So what I'm going to do now is I'm going to fill the cup about halfway. Now I'm going to pour it into the Hero's Engine. I want to hold it, that way it's not spinning until I pour all of the water in, right? It's just a lot easier. I have a device holding it in place, but you can have somebody holding it and somebody pouring the water. So I'm going to go ahead and I'm going to fill the Hero's Engine about halfway. Alright, and when it starts going back around, you want to stop counting. You can see it spun around. I would count that about 2.5 times, right? So now, what you want to do is you want to just let it sit, or you want to untangle this, the string, because the string could throw off that data. So you do want to let it sit for a little bit, just so the string is not coiled. So now what I'm going to do is I'm going to fill the Hero's Engine up all the way, and then we're going to count the number of spins. So you can see now I have the cup filled almost up to the top, and we're going to pour it into the Hero's Engine and we're going to count the number of times it spins. All right, so if you were counting that, it went around about 5.5 times. Now you can see it's going the other way. That's just the string unspooling. So now we have to ask ourselves the question, why does the Hero's Engine spin when water is added to it? And to do that, we look at Newton's third law. For every action, there's an equal and opposite reaction. Think about it this way, right? The water is going out the straws are bent. The straw is pushing that water out. Think about what the water is doing to the straw. Think about Newton's third law. For every action, there's an equal and opposite reaction. So, as you can see, the more water that's in the cup, the more times it spins. Think about why that is. Now, the Hero's Engine does a really great job of representing how rockets work in space. Another thing you can think of is, would the Hero's Engine spin if the straws were straight? Why does it spin when the straws are bent? I'll put water in the cup with the straw straight and we can see if it spins. So notice the Hero's Engine isn't spinning when water is applied to it and the straws are straight. Once again, this is the Hero's Engine.